Upgrading ungrounded receptacles in a house requires careful attention to safety and proper grounding techniques. Firstly, it is critical to turn off the main breaker in the electrical panel. Verify that the power is off at the receptacles before beginning any work. Secondly, if the house does not have grounding electrodes, they need to be installed. This typically involves driving two 8-foot copper rods into the ground at least 10 feet apart. These rods will connect to the service neutral wire in the panel and provide a path to ground. Next, install a new bare copper grounding wire, typically 12 gauge or larger, from the grounding electrode or electrodes to the electrical panel. Connect this wire to the grounding bar in the panel. After that, from the grounding bar in the panel, run a bare copper grounding wire to each grounding receptacle location. Use staples or straps to secure the wires to the studs or joists. Once the grounding wires are in place, connect the receptacles. Connect the grounding wire to the green screw terminal on the receptacle. Connect the white wire to the silver screw terminal, which is the neutral. Connect the black wire to the brass screw terminal, which is the hot wire. After connecting the receptacles, turn the power on. Use a ground fault circuit interrupter or GFCI receptacle tester or a multimeter to verify that the receptacles are properly wired and grounded. Once the grounding wires are in place, replace all of the remaining ungrounded receptacles with grounding type receptacles. It is important to use appropriate safety precautions when working with electricity. Always turn off the power at the main breaker before beginning any electrical work. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a licensed electrician to perform the work. Grounding is an essential safety feature in electrical systems. It provides a path for fault current to flow back to the source, which trips the circuit breaker and energizes the circuit. This helps to prevent electrical shocks and fires. Ungrounded electrical systems can be dangerous. If a fault occurs, the metal parts of appliances and equipment can become energized, which can create a shock hazard. Grounding helps to mitigate this risk by providing a safe path for fault current to flow. When installing grounding electrodes, ensure that they are driven deep enough into the ground to make good contact with the earth. The depth required may vary depending on the soil conditions. The grounding wire should be securely connected to the grounding electrodes and the grounding bar in the electrical panel. Use appropriate connectors and ensure that the connections are tight. When running grounding wires to receptacles, avoid sharp bends or kinks in the wire. Use staples or straps to support the wire and prevent it from sagging. When connecting receptacles, ensure that the wires are properly connected to the correct terminals. The grounding wire should be connected to the green screw terminal, the neutral wire to the silver screw terminal, and the hot wire to the brass screw terminal. Use a GFCI receptacle tester to verify that the receptacles are properly wired and grounded. A GFCI receptacle tester will check for common wiring errors and verify that the GFCI protection is working correctly. If you find any wiring errors, correct them before using the receptacle. Replacing ungrounded receptacles with grounding receptacles can significantly improve the safety of your home's electrical system. Grounding provides a path for fault current to flow, which helps to prevent electrical shocks and fires. By following the steps outlined in this guide, one can safely and effectively upgrade the electrical system. Remember to always prioritize safety when working with electricity. If possible, use ground fault circuit interrupter or GFCI receptacles throughout the house for added safety. Ground fault circuit interrupters or GFCIs are designed to protect people from electrical shocks. They work by monitoring the current flowing through a circuit and tripping the circuit breaker if they detect a difference between the incoming and outgoing current. This difference indicates that current is leaking to ground, which could be a sign of an electrical fault. Ground fault circuit interrupters, or GFCIs, are particularly important in areas where water is present, such as bathrooms, kitchens, and outdoor locations. Consider installing a whole house surge protector to protect electronic devices from voltage spikes. Surge protectors are designed to protect electronic devices from voltage spikes, which can damage or destroy sensitive equipment. A whole house surge protector is installed at the electrical panel and provides protection for all of the circuits in the house. A surge protector will help to protect against damage from lightning strikes, power surges from the utility company, and internal surges caused by appliances and equipment. Hire a licensed electrician to perform the work if you are not comfortable working with electricity. Electrical work can be dangerous, and it is important to have the work done by a qualified professional. A licensed electrician has the training and experience to safely and effectively perform electrical work. An electrician can also ensure that the work is done in compliance with local electrical codes. When upgrading the electrical system, consider any future electrical needs. This may include adding new circuits for appliances or equipment, or upgrading the service panel to handle increased electrical load. Planning ahead can help to avoid costly and disruptive electrical work in the future. Ensure that all electrical work is done in compliance with local electrical codes. Electrical codes are designed to ensure the safety of electrical systems. They provide guidelines for the installation, maintenance, and repair of electrical wiring and equipment. Complying with the electrical codes helps to prevent electrical shocks, fires, and other hazards. When working with electrical wiring, always use appropriate tools and materials. This includes insulated tools, wire connectors, and electrical tape. Using the correct tools and materials helps to ensure that the work is done safely and effectively. When connecting wires, make sure that the connections are tight and secure. Loose connections can cause overheating and electrical fires. Use wire connectors to make secure connections and electrical tape to insulate the connections. When installing receptacles, make sure that they're properly mounted and secured. Receptacles should be mounted in electrical boxes and secured with screws. This helps to prevent the receptacles from coming loose and creating a shock hazard. When working with electricity, always be aware of the potential hazards. Electricity can be dangerous, and it is important to take precautions to avoid electrical shocks and fires. By following these safety tips, one can safely and effectively upgrade the electrical system. Use a voltage tester to verify that the power is off before working on any electrical circuit. A voltage tester is a simple and inexpensive tool that can save lives. It can be used to verify that a circuit is de-energized before one begins working on it. Never work on electrical circuits when wet or standing in water. Water is a good conductor of electricity, and it can increase the risk of electric shock. Avoid wearing jewelry or other metal objects when working on electrical circuits. Metal can conduct electricity, and it can increase the risk of electric shock. Never overload electrical circuits. Overloading a circuit can cause the wires to overheat and start a fire. Only plug in appliances and equipment that are rated for the circuit's amperage. Use extension cords safely. Extension cords should only be used temporarily and should not be used to power high wattage appliances. Make sure that the extension cord is properly rated for the appliance or equipment being used. Inspect electrical cords and plugs regularly for damage. Damaged cords and plugs can create a shock hazard. Replace any damaged cords or plugs immediately. Have electrical work inspected by a qualified electrician. This will help ensure that the work is done safely and in compliance with electrical codes. Remember that electrical codes may vary by location. The National Electrical Code, or NEC, is a widely adopted standard for electrical safety in the United States. However, local jurisdictions may have their own electrical codes that are more stringent or that address specific local conditions. It is important to consult with local building officials to determine the applicable electrical codes for the area. The size of the grounding wire required for a receptacle circuit depends on the size of the circuit breaker protecting the circuit. According to the National Electrical Code, or NEC, Table 250.122, a 15 amp circuit requires a minimum 14 American wire gauge, or AUG, grounding wire. A 20 amp circuit requires a minimum 12 American wire gauge, or AUG, grounding wire, and a 30 amp circuit requires a minimum 10 American wire gauge, or AUG, grounding wire. It is always a good idea to use a grounding wire that is larger than the minimum required size. This will provide a greater margin of safety and help to ensure that the grounding system is effective. When running grounding wires, it is important to avoid creating ground loops. A ground loop occurs when there are multiple paths for ground current to flow. This can cause noise and interference in electrical circuits. To avoid ground loops, make sure that there is only one path for ground current to flow from each receptacle to the grounding bar in the electrical panel. When connecting grounding wires to receptacles, it is important to make sure that the connections are tight and secure. Loose connections can cause the grounding system to be ineffective. Use a wire connector to make a secure connection and tighten the connector with a wrench or pliers. When installing grounding electrodes, it is important to make sure that they are driven deep enough into the ground to make good contact with the earth. The depth required may vary depending on the soil conditions. In general, the grounding electrode should be driven at least 8 feet into the ground. When connecting grounding wires to grounding electrodes, it is important to use a grounding clamp that is listed for the purpose. A grounding clamp is a specialized connector that is designed to provide a secure and reliable connection between a grounding wire and a grounding electrode. When installing a whole house surge protector, it is important to follow the manufacturer's instructions carefully. A whole house surge protector should be installed by a qualified electrician. A whole house surge protector can protect electronic devices from voltage spikes caused by lightning strikes, power surges from the utility company, and internal surges caused by appliances and equipment. When using ground fault circuit interrupter, or GFCI, receptacles, it is important to test them regularly to make sure that they are working properly. A ground fault circuit interrupter, or GFCI receptacle can be tested by pressing the test button on the receptacle. If the receptacle trips, it is working properly. If the receptacle does not trip, it should be replaced. Ground fault circuit interrupter, or GFCI, receptacles should be installed in all areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. When replacing ungrounded receptacles with grounding receptacles, it is important to label the receptacles to indicate that they are grounded. This will help to prevent confusion in the future. The receptacles can be labeled with a sticker or a permanent marker. When upgrading the electrical system, it is important to consider any future electrical needs. This may include adding new circuits for appliances or equipment, or upgrading the service panel to handle increased electrical load. Planning ahead can help to avoid costly and disruptive electrical work in the future. It is important to maintain the electrical system regularly to ensure that it is safe and reliable. This includes inspecting electrical cords and plugs regularly for damage, testing ground fault circuit interrupter, or GFCI receptacles regularly, and having the electrical system inspected by a qualified electrician periodically. Maintaining the electrical system will help to prevent electrical shocks, fires, and other hazards. One must ensure that all electrical work is done in compliance with local electrical codes because electrical codes are designed to ensure the safety of electrical systems. They provide guidelines for the installation, maintenance, and repair of electrical wiring and equipment. Complying with the electrical codes helps to prevent electrical shocks, fires, and other hazards. When working with electrical wiring, use appropriate tools and materials, like insulated tools, wire connectors, and electrical tape, because using the correct tools and materials helps to ensure that the work is done safely and effectively. When connecting wires, the connections should be tight and secure, because loose connections can cause overheating and electrical fires. Use wire connectors to make secure connections and electrical tape to insulate the connections. When installing receptacles, ensure that they are properly mounted and secured. Receptacles should be mounted in electrical boxes and secured with screws. This helps to prevent the receptacles from coming loose and creating a shock hazard. When working with electricity, one should be aware of the potential hazards because electricity can be dangerous, and it is important to take precautions to avoid electrical shocks and fires. Upgrading an ungrounded electrical system to a grounded system is a significant undertaking that requires careful planning, execution, and adherence to safety protocols. By following the steps and guidelines outlined, and by prioritizing safety at every stage, one can enhance the safety and reliability of a home's electrical system. If there is any doubt or uncertainty about any aspect of the process, it is always advisable to consult with a qualified and licensed electrician who can provide expert guidance and assistance.